Hello, I am Corey Dotson.
I'm Vinwin.
And I'm Samuel Duran, and this is our windmill simulation.
The simulation project consists of three parts: the AC generator, the rectifier, and the comparator. So now we'll be talking about each part individually.
So this is a generator. The purpose of the three-phase generator is to simulate the output from a windmill. And so the wind would hit the windmill and turn the shaft powering the generator. But because the wind is always changing, we use an AC output to reflect the altering wind speed. And then now Vin, he'll talk about the rectifier.
Okay. In the rectifier, what happens is that the wind generator inputs a three-phase AC generator, but we want to have a one-phase DC voltage outputting. In order to do this, we'll use what is called a rectifier. This rectifier uses a set of diodes in order to control the flow of voltage. So with the way these diodes are set up, the voltages can only flow when it is positive. And because these sets of diodes are in parallel, it'll always output the most positive voltage. So this yellow line represents the output. And because initially after the output, it follows this waveform still, it's still AC. We mitigate this by using our capacitor right here. What this capacitor does in the rectifier is it discharges and charges depending on the changing voltage level. And because of this, we'll always maintain a steady voltage and avoid any jumps or changes. And with this rectifier current, or rectifier voltage, I'm sorry, it will feed into the comparator, which is what Samuel will talk about.
So the voltage that enters from the rectifier will feed into each of the four comparators. We'll begin by looking at the topmost comparator. Essentially how this works is there is a voltage divider on the left-hand side. The voltage output that's fed into the comparator at 0.5 is equal to R2 over the sum of R1 plus R2 multiplied by VDD. So in this case, it would be 100 over 500. This gives us 0.2 multiplied by 10 is 2 volts. If the voltage from the rectifier is greater than 2 volts, in other words, if the voltage at 0.4 is greater than the voltage at 0.5, the comparator switch will close and current will flow through. Voltage source VCC will then feed LED 1 to indicate that there is a voltage greater than 2 being fed into the system. This is true for all four comparators. If we look at comparator number 2, for example, that is the voltage fed at 0.7 is 5 volts. If the rectifier voltage is greater than this 5 volts, LED 2 will light up. If the voltage is greater than 7 volts, LED 3 will light up. And if it's greater than 9 volts, LED 4 will light up. Next, we'll do an overall analysis to explain how this whole combined circuit works.
So to do a final run through of the entire design, generator 2 will input a three-phase AC voltage into our rectifier. And in the rectifier, we will convert that into a single-phase DC voltage. The single-phase DC voltage will then feed into the comparator, and at each comparator, it will turn on or off depending on the voltage level of the circuit. So this is our circuit running at 10 volts. So as you can see, all the LEDs are turned on because the voltage going into the comparator is 13.3 volts.
Yeah, so we're gonna simulate some lower wind speeds for the generator. We can give it less output, and then we'll see the LEDs change.
So in this one, we half the generator's max voltage, and as a result, the voltage going into the comparator is 6.3 volts now, and only 2 LEDs are on. So the 2 volts and the 5 volts comparators are on, and the 7 volts and the 9 volts are not on.
LED indicator 5 is simply showing that that the whole circuit is working properly and that there's power flowing through. And LED light number 5 should turn on in any case when there is power entering the system, even if it's below the 2 volts from the first comparator.
That is our windmill design project.
Thank you.